So let's keep going. Now we're going to talk about prediction. So if you recall the third exam and the final exam examples, we examined the scatter plot and showed that the correlation coefficient is significant. We found that the equation of the best fit line for the final exam grades as a function of the grade for the third exam. We can now use the least squared regression line for prediction. Suppose you want to estimate or predict the mean final exam score of statistics students who received a 73 on their third exam. The exam scores X values range from 65 to 75. Since 73 is between the X value of 65 and 75, we can substitute X for 73 and put it in the equation. So we can predict that statistics students who earn a 73 on the third exam will earn a grade of 179.08 on the final exam on average. Is that exact? No, but we're just estimating. So if you recall again the equation, what would you predict the final exam score for a student who scored a 66 on the third exam, or for a student who scored a 90 on the third exam? Go ahead and pause the video and try these out. Okay, for the 66, you would just plug it in, you'd get 145.27. All right, for the 90, it was kind of a trick. So you can't use it because the X values only go between 65 and 75, and 90 is outside the domain of those X values. But even if you were to put it in there and you put the 90 in there, you can see it gives you a value of 261.19. And if the final exam can only be out of 200 points, you know you did something wrong. So you always need to be mindful that your X's, your values that you're predicting with don't fall outside the range. So interpolation and extrapolation. In the process of predicting inside observed X values observed, we call it interpolation. And the process of predicting outside of the observed X values observed in the data is called exploration. So these are just two things that you need to know about what they do in statistics. So let's talk about outliers. All right. So in some data sets, there's values called outliers. These are data points that are far away from the least squared lines. They have large errors where the error or the residual is a vertical distance from the line to the point. Outliers need to be examined closely. Sometimes for reasons or another, they should not be included in the analysis of the data. It is possible that an outlier is a result of extraneous data. Other times, an outlier may hold valuable information about a population under study and should remain in the data. The key is to examine carefully what causes a data point to be an outlier. So, you can guess by looking at outliers on a graph. A rough rule of thumb is we can flag any point that is located further than 2 standard deviations above or below the best fit line as an outlier. The standard deviation used is the standard deviation of the residuals or the errors, the SSE we looked at before. There's 2 ways you can do it. You can do it graphically or you can do it with numeric calculations. Let's go ahead and look at the graphic way. It might help, okay? So I'm going to post out of this and I'm going to bring my calculator up, okay? Oops, not that, but this. Okay, so I still have my data in there. And you can see I still have my line of best fit, okay? I still have it right there. So what I'm going to do now is I'm going to go ahead and let me go to second Y, and I'm going to turn on let me go enter. I'm going to turn it on, so it's on, and then I'm going to pick my scatter plot again. It's on. L1 is where X is, Ly is where X is. Keep going down and then hit enter. It'll let me. Okay, so then I go to zoom stat, and there's my scatter plot, okay? There's all my variables. Okay, and now I want to put my line of best fit. So what I'm going to do is I'm going to do negative 173.51, oops. For some reason it keeps thinking it's log in my calculator. Okay, 0.51 plus 4.83x. Okay, so then I hit Zoom 9, and look what it did. Okay, that is my line of best fit. Well, the next thing I need to do, let me scroll down is here, is I need to find out the 2 standard deviations above the line of best fit and below the line of best fit. So what I'm going to do this, I'm going to go stats, I'm going to go over to test, and I'm going to scroll down to linreg t-test, and it's right here. For me, it's E on my calculator. I hit enter, and I'm going to go down, and I'm going to keep everything the same, and then I'm going to hit calculate. So if you scroll down, you're going to see an S. So that is my sum of squares errored, or the standard deviation for that. So for this one, it's 16.412. So there I have it, 16.412. So that's what I'm going to use. So what I'm going to do is I'm going to take right here my line of best fit, and then I'm going to subtract 2 times 16.4, because that's 2 standard deviations below the line of best fit. And then I'm going to do it again. Here's the line of best fit plus 2 times 16.4. Okay, so I'm going to go back to Y, and then for Y2, I'm going to go ahead and put negative 17.51. Oops, does it again. Let me do that. 0.51 plus 4.83x minus 2 times 16.4. Oops. I'm just figuring it really bad today. Times 4. And then I go down to this, and then I do negative 173.51 plus 4.83x plus 2 times 16.4. All right, so I've got it in there, right? So then what I do, I'm going to go zoom and do 9 again, and look what it did. Okay, so here's my line of best fit. Here's the line that is 2 standard deviations below it, and here's above it. Well, look right here, this value right here. That is falling outside that range, so I could predict that that is an outlier. So what I'm going to do is I'm going to look in my actual data and find the point. So if I go back to my calculator, I know it's going to be, let's see, I don't know if I can zoom in. Can I trace? Oh, look, I hit trace, and look what it did. It gave it to me. X is 65, Y is 175. I hit that trace function, and it told me exactly what it is. So because it's outside the lines, the outlier is the student who got a grade of 65 on the third test and is 175 on the final exam. So the point is further away than 2 standard deviations away from the line of best fit. This is actually a really great way to use the calculator, because here's all the data and you can see it graphically. Okay, so there's another way. There's numerically. And you might want to try to do this in a table in Excel, or you can make a table in your notebook. So in your first column, you're going to have your X values. In your second column, your Y values. And then your third column is going to be the values that you get when you put X in for your line of best fit. We call it your Y hat value, or your predicted value. The fourth column is going to be Y minus Y hat, and we call that the residuals. And if you see here for that data, I went ahead and worked everything out by hand. So here's my X values, here's my Y, here's how I got Y hat. So here's our line of best fit, and I put here, for this one in particular, I put 65, which is my X value, and got 140. So then over here, I did 175 minus 140 gives me 35, okay? So there are my residuals. So then my next step is I'm going to go back to remember how I got my standard deviation. I go, let me turn it back on. I go stat, I go over to test, and I go down, I think it was E. Yep, then I hit enter, and I scroll down to calculate, and then I go all the way to the bottom, and I get here, S equals 16.41, okay? So what I want to do is I want to multiply it by 2 and then by -2. So I get 32.8 and negative 32.8. So what I want to see is, does the residual, is it above 32.8 or below negative 32.8? So if I go look over here, all my residuals look pretty good except for this 35. And again, it's that point where X is 65 and Y is 175. So that is a potential outlier. So sometimes you can remove outliers, but I'm going to warn you, you've got to be very, very careful of this. So when you said we said this was an outlier, we're going to re-examine our data to see if there's any problem with it. If there's an error, we need to either fix the error or delete the data. If the data is correct, we just leave it. So for this problem, suppose we found that data and we found that that data was an error, something was put in incorrectly. So what we do is we delete it, and then we go back through and we run the whole thing again using the linreg or the linreg t-test, and we get a new line of best fit and a new R. So in that new line, R is 0.9121, which is a very strong positive correlation, and it's stronger than the original one of 0.6631. So that means the remaining 10 data values is a better predictor than the 11 when we took out the outlier. Why do we know that? Because of this R value.